welcome back to deploying application. So, in this video, we will discuss how to deploy an application, different parts or different ways to deploy. We have touched on this already with my full stack blogging website. Along the road, we will provide further example for this, but in this, we will dig deep dive. We will dig into the theories and details of deploying it. So, metaphor for this would be construction. So we have defined the intricacies of software components. Now it's time for us to construct the building for good so that it will be available uh, for visit. So it's just like that's a metaphor for deploying our application. So for build, so this is one of the most complex topic. So if you don't get it at first, that's fine. You can just reiterate or try to um, relearn it again because there's a lot of debugging steps. The reason for that is just like an old construction. Instead of like you have to know how the bricks or each part of the house will integrate with the new house or with the new building. So there's a lot of factors to consider. That's why it's complicated. Now we're actually trying to make the app work in the real world. So just like building, you have to define the requirements of the customer. You have to meet the requirements, right? You have to have like electricity, water. You have to be liked by your customers that will occupying the building. So that's the reason why it's complicated. So first, this process includes, for example, compiling source code into machine code. Here is the diagram for that. So all the codes that we have created earlier uh, will be compiled now to a machine code so that a computer can read it. So here is source code. We built it, a web application, and then we deploy it to uh, server. So we call that server that hosts our web application as the host. And then that host will serve our application to the internet or the user. The build process can be executed on a development computer or on a special build server. The latter is particularly advisable when working in a team or uh, for elaborate build process. So if you're working as a developer in a big company where which will you most likely will you will use this special build server, which is the version control system. I know you've heard of this, which is GitHub. So you push your source code first. You make sure that you got the recent source code. There's no other pending changes or updates. And then after you do that, then you make your necessary changes and then you push that to the central repository. And then for deployment, the step to transfer the built web application from the development to the server that deploys the web application over the internet is referred to as deployment. So host, the server that provides web application to users is called a hosting server or host for short. Hosting is not really step but rather a state. A hosting server hosts the web application. You can rent a hosting server or some web space, i.e. the storage space you need for your web application via a hosting provider. So you can host it via hosting provider. In addition to the website, you also need a domain like. So in addition to the host hosting provider, like AWS or Azure. You also need a domain name like cleancoder.com so that users enter it in a browser and possibly secure socket layer or SSL so that you can deliver it securely. So for the browser to know from which server to load the corresponding web page, it requests the IP address of the server with the URL from a domain name system. So this is the first topic that we have. DNS server convert this domain name to your actual IPv4 address or IPv6 address. Types of deployment first, FTP. Uh, so these are one of the types of deployment and one of the old ways. So to do this, you need to have FTP client and then FTP server. So it allows you to transfer files from one computer to another. So basically, you're transferring your source code as it is so that it could work on the other computer or on the hosting server. Because, like what I've said, those hosting server could have different operating system, different environment. That's why it could be complicated if we don't have this FTP client. Using FTP client, you can connect to the FTP server already installed on the hosting computer. So most hosting providers have this FTP client, like AWS, Azure, or any cloud provider, or any operating system. Using known FTP clients include FileZilla, CyberDuck, Forklift. If not, you can easily download that using .exe file or in Microsoft or Apple Store. The secure shell-based SCP allows you to copy files securely from one computer to another. Another thing with this FTP is that the secure uh, type of this is SFTP, kind of like HTTP to HTTPS. The secure shell base allows to copy files. For this purpose, you need an SCP client. So it's the same. You need an SCP client to manage this. So basically, what we want to dig dive in this chapter is the container management. So here is the container. In terms of deployment, you can use Docker to package your web application into what are called Docker image, usually directly together with the corresponding web server to run the web application. So think of Docker as like a prefabricated module that allows you to a module of materials that allows it to be adaptable to different environments. So instead of always checking or considering the unique features of the environment, you build a software component that will be adaptable to most environments or to all environments. So that's the innovation of this. Here, you have Docker client. You create a Docker image. So this Docker image is like um, think of this as a shipping container. It could be thought of a shipping container as well. This Docker image is like the definition of a shipping container, how big it is, uh, what are the products that could be put to it. So it innovates the way goods are transferred, right? The shipping. Now, this Docker image, you upload this to a Docker registry. So you register it to a central shipping company or to the government that handles the shipping. And then that image are downloaded from the client or from the server. So this image is downloaded, the definition. So basically, this image is just like blueprint of the shipping container, and that blueprint can be now used to create your own instance. So it's like that plan or blueprint can now be used to create your own container that fit to your environment. In that case, you need to download Docker on your app, and then you just run this. the Docker, and then run the corresponding image. So this registry is like a central um, shipping, right? Shipping container that records all that have all the records of shipping image, and that shipping image can now be downloaded to any part of the world. So that's a metaphor for that. Types of hosting, shared hosting. Shared hosting, so whenever you're trying to make your software available or your building available, it depends of type of software you have. Sometimes the software will fit on a shared hosting or in a bed space or like a dormitory structure building. Virtual private hosting is suitable whenever you want to host a web application that should be able to handle a high number of concurrent users. Moreover, with VPS hosting, you can usually flexibly increase resources if you find that. So, virtual private hosting is like uh, what would be the let me check the metaphor for this virtual private hosting. Okay, so we don't have a metaphor for this. So dedicated hosting is like think of this virtual private hosting like this. So here's the shared here. Um, your environment is isolated, but you can somehow uh, scale it because it's larger than this. So here for small concurrent users, here for slightly larger concurrent users. These are for high concurrent users. So dedicated hosting is a good choice if you have particularly high requirements. So it's like owning your own restaurant. Shared hosting is like owning a food stand in a food court. Dedicated hosting is like owning your own restaurant. Cloud hosting, one type of food. So cloud hosting, you can think of this as like a dynamic resource that like an ultra modern building propagated module that allows you to dynamically scale building wherever you are in the world. So it's like digital. Uh, so one of the hosting that has become increasingly popular in recent years is cloud hosting. So in this case, your web application sometimes run on multi-port server or on cloud infrastructure formed by network of server. Cloud is particularly suitable if you want to scale. So these are for scaling concurrent users. So this is started the diagram for this. Now, what happened in web development is that first, we have a static website, HTML, CSS, right? And then that are easy to implement. Second, we make it dynamic, HTML, CSS, and JavaScript. So that's Web 2.0. And then that makes things more complicated. So what happens is that it makes it faster for user. It provides better user experience because the system is not static. It interacts with the user data, but it also makes the development complicated for the developer because now the developer would think about JavaScript on how they can make the program dynamic on how they can package the app and deploy it to a server, right? They now have to think if they're going to use shared hosting, uh, virtual private hosting, cloud hosting, etc. So if you have a static application consisting only of hypertext, so yeah, it's you can use S3 for this in cloud as well, but you can also use your own private server. Dynamic web application, if web application is dynamic and consists of a part that must execute server logic, among other things, which programming language implements the server-side logic is important. So do you use JavaScript to implement the logic? Then you must have an appropriate runtime, which is Node.js, because JavaScript server will only run on Node.js or JavaScript runtime environment. Do you have Java? So that will only run on Java runtime environment. So we've discussed this Java and JavaScript on my full stack car front app that was created using Java or Spring Boot, and MERN app using Node.js or JavaScript. Web application with a database. If you implemented a dynamic web application, most likely you also need. So this is the diagram of that Node.js. Now, if you implemented a dynamic, you also have database. As you can see, guys, these are three Docker image. It's the same with my app. Remember, I packaged it in three different Docker files. So we will discuss further Docker in the later. So here you also have database, not just the backend and the image. So now you don't just have to worry about deploying this static on the front end. Or actually, it's not static. It could be dynamic now. And then backend, you also need to deploy the database. Full stack server. Basically, the requirements for the server on which a web application runs are derived from the components used on its underlying stack. So what that means is that the way you deploy, the more interactive and the the more interactive your app is. Oh my god. How about All right. So, the more interactive your app is, the more you need um, uh, a complex way. So basically, it's easier for the user, but it's more complex for developer. So the more you add to the server must the requirements for the server are dependent on your underlying stack. So the more complex, the more you make your feature fancy, the more complicated the system becomes. Server must therefore provide entire software infrastructure to run the respective application. In other words, you need a full stack server. Docker can considerably reduce the amount of work related to install or deploy the software infrastructure. So just like what we mentioned, so what happened with containerization, such as Docker or Kubernetes, um, is that they make the software components run on different environments. So it's hard. You will do a lot of troubleshooting to make it to contain your app at first, but after you deploy it, it's just a matter of Git or deploying it on the your Visual Studio Code. So benefits of Docker, the benefits are huge for developer. Instead of having to install all software components separately in your system, you can simply launch the corresponding component via Docker. For one thing, this approach keeps the development machine clean, and second, you can also exchange Docker image with other developers very easily. Similarly, containers provide software standardization. Once an application is encapsulated within a container, it behaves identically regardless of where it is deployed, whether on a developer's laptop, a testing server, or a cloud-based environment. The container ensures that the software remains consistent. This eliminates the infamous works. So this eliminates the issue of works on my machine. So have you ever had that excuse with your coworker or with people that it works on their machine, but it doesn't work with the other? So Docker significantly removes this. Deployment with Docker using Docker file. So by default, we use Docker file. You create a Docker image that contains your web application based on this Docker file. So creating the configuration for the Docker image. To create a Docker image, you need a configuration file, which by default is named Dockerfile. In this file, you can define individual steps to be performed in order to create the Docker image. The file thus acts as a blueprint for a special Docker image. Basically, various commands are available in a Docker file that you can use to define individual steps, for example, to copy files, install software packages, or execute certain command line commands. Creating the Docker image with the Docker image file as a basis, you can now build Docker image using the Docker build command. So here's the example, guys. Docker file. So we specify the runtime environment, which is the node 14, work directory, user slash src slash app copy. So we copy the package, the JSON from this, and then we run npm install, so that, because remember package.json has all our metadata of our dependencies. Now when we run npm install, those image will install the dependent environment, and then we copy the rest of the app files and then expose the port, and then we start the application using our command line node server.js, depending on our first or intro file. So basically, this Docker file simplifies it, right? This is, if you're wondering how is it written, it's written in Go, and it has like 2 million lines of code. So it's complex, but it makes the development easier. Number of Docker image. So the way we build this, this is a command, guys. So Docker build dash t and the name of your app, and then Docker build the database, the directory name. So I stopped the my app, which is the name of the app earlier. And then this is how we run it. Docker run dash d dash p, and then the port of the local host, and then the port of the container. So name my app. So we will gonna discuss this further, because like what I've said, this is one of the most complex. Docker Compose. Using Docker Compose, you can use configuration files in YAML, in markup language format, to configure multiple Docker services and define dependencies among them. So version, we put a version services front end. So here, image, with this setting, you define the Docker image to be used in our example, clean coder front end. So Docker Compose are used to contain front end and back end. So if you want to contain it in one file, you use this. Or if you want to contain front end, back end, or database, we will discuss this further in the next videos. I'll just stop it for now because I know it's too much. So to sum it up, we've discussed different types of deployment, FTP, SCP, and containerization. So we dig into containerization, which is the most useful. So we compare it like a prefabricated module of a construction today, or a shipping container that innovates or make the shipping of goods, or shipping of creation of building faster for developer. We've also discussed some history of web, on how it evolves from static now to dynamic websites, and on why are we using Docker today. Again, thank you for watching, and see you on the next video. Peace.